Hey guys, Josh and Dory's Customs here. Thought I'd get back into this second part video that we've got lined up. Basically, we touched on the Bronco on the first episode, which was stripping down our chassis, working our way back through to the midsection of this car. We went through, we've dressed all of the chassis up and fixed areas and stuff. It's all nice and clean and then prepped with a U-Pol copper primer. This, I've talked about the previous video, but this is basically our foundation to weld on and then paint on as a primer. The next sort of portion, which we chucked on this cross brace, which is going on now, a bit of modification to that because one side's going to be steering pump. We flipped that from America, so sections don't work. I do have to just scan this chassis here and make some infill plates on the back section, and then the tops tubes that come down here is the verticals. We just need to knock 6mm off the bottoms of that with a Sawzall while it sits in there, and then we just sandwich in some little plates and tie into the chassis. Probably be all right in America with this kind of stuff not being sandwich plate and all that shit. They get away with it, but in Australia you still need to tie into the chassis a bit of a fish plate kind of section, just to sort of spread that load over its distance and stop cracking in the chassis and that. So that's where we got to with that. Moving forward where we're at now, obviously that center section's on now of our tie-ins. This particular piece here is made out of Billet, which is our cross piece. Look, yes, it's definitely excessive, but this build for me is something that I want to be everything. I don't want to look at it and go, it would have been nice to have that. Time is something I'm happy to wait for the end product. So that's why we've gone down that path. In here, you can see that we've got our shocks. These are Cerakoted 12-inch internal bypass coilovers. They are a 3.0. Reason being the 3.0 is because they don't run a true size piston inside of the Foxes. The way that the internal bypass works, I believe, is a lot better in the Foxes in terms of the actual physical size inside of it. It does underspec down to a 2.5. So a 3 is a 2.5. If you're in Kings, a 3.0 is a 3.0. But you have limitations on how that internal bypass works, and it's mainly only rebound, kind of setup that you're tuning. With this, we're doing compression and everything like that because it does have a double layer tube which has shim stacks which bypass the outside layer. So it depends who you are, horses for courses kind of thing. But I believe the Fox is sort of at the top right now in terms of how they work and what you get for it. Just depends. I would probably put down to Kings as being more robust and probably more agricultural in design, but more sustainable too. You'd probably see 10 plus years out of them. With these, if you don't look after them and do regular services and get the grits out of them and all that stuff, you'll eat the hell out of these and they'll fuck them up. So take that into consideration. We pulled the pump off. I went through it. It's not leaking. It's pretty good. We'll see how it goes on the car. If it does have issues of seals, I'll do them. At the moment, there's no point to open something that doesn't need to be opened. So pretty much just heated it up to certain spots to alleviate that kind of grease that built up in there. And then once again, hit it with Steelit. It's just a nice paint to sort of dress up things. So that's sort of where we got to that point there. And then the next point would be the beam. So originally they weren't really fully welded out. Now I've welded them all out, and we still have to do a couple of extras on there. So we need to tie in our coilover brackets. We need to tie in our radius arm brackets. We need to lop off the bush section and replace it with uniball. And then what else we need to do? Sort of pretty much where we are. We'll chuck some bumps on and that once we get sort of cycling. And yeah, it'd be nice to sort of, that's my main focus at the moment is suspension and movement. So anything that's suspension related is my current focus of this build. So through this video, we'll pretty much start building on that. Talk about a couple of other things. Tyre selection, probably can't see it, but these are a BFG Goodrich. So 35-inch KM3 Baja kind of design spec, back on my methods. And then we're running a 5/8 stud upgrade with a trophy truck kind of lug on the end of it. Or wheel nut, if you want to call it. Reason being, this particular tyre, I like the aesthetics of it. I like the look of it. In sand and stuff like that, it does perform well. On the road, they do not. They're not the best of tyres, the Sipes and all that kind of stuff. That you slide down the wet with BFGs a fair bit. Overall, the designs of KO3s, KO2s, KM2s, KO or KM3s, all the designs, I just don't think they've ever gotten better at traction control in the wet on the road. But look, it is what it is. I just like this look of this tyre, so we've stuck with it. One thing you'll notice is this car makes 35s look so tiny, but when we talk legalities, this thing is going to go on the road, and basically a 31570 R17 is what we need to spec out for this car to be registered on the road under a swerve test. Unless you did push and go massive GVM and put diffs that suit a certain tyre selection, that's pretty much as far as we can push this. We'll go through and talk about some parts, and we'll go through the fabrication of it, everything like that. But pretty much the only part I'm really waiting on the end now is Brembo. So the actual brake assembly on this, I'll show you on the knuckles, but we've stripped down another Dana 44 TTB setup, and I've got that already. I've got just some modifications to the actual cast knuckle section. But we use an adapter plate to run the 6-pot piston Brembos, and that will step us up to a 5/8 stud too. So sort of can't get this cycling just yet because the way that it stacks on the actual spindle section, you do have your Brembo, then like your caliper bracket, and then you have your flange for your hub, and then your studs go through that. So I can't assemble it just yet, otherwise I'd be putting the splines through the hub and then I have to press them back out. The studs are not cheap, so I don't really want to fuck them. So consideration there. But pretty much we'll get into it, and I reckon we start addressing the beams and we start getting into the knuckles. I'm currently up the point where I've stripped out the old TTB knuckles and I've just cleaned them up. I've got a bit of a box in here with everything that I do need to retain. So we do have our spindles in here. Sort of to go through food for thought with my kind of, analysis on this kind of stuff is spindles, undersized, knuckles, not enough beef in them. I know all this shit holds up, but I don't like how small it actually is, so I probably will look down the path of maybe a reed knuckle and maybe making my own spindles out of 4340 or something, see where we go with that. It's sort of a bit limited what you can do. I don't know if you can upgrade to a Dana 60 spindle, but the only issue with that is then you change PCD and stuff like that, and your hub centers get bigger, so you can't run that 110 kind of profile bore on your rim. Just food for thought there, but definitely want to make it a bit stronger. Especially the next part I'm about to tell you is we need to make these smaller. So the Brembo kit, I don't know if I can't remember if it's 4-pot or 6-pot or whatever it is, but what we need to do is we need to make provision for our adapter plate. So our adapter plate will come off the back side of this and now pick up our new Brembo. The issue is that this casting sits in our area, so we need to cut this off. So basically, this line from here to here, this section here to here, cut it completely off. And how we do that is either going to be the Sawzall or we're going to do it in the bandsaw. A grinder, you will sit there for quite a while doing it with a grinder. You will get it, but just sit there for a while. The aggressive blades that you get from most brands now, like Milwaukee, Lennox, and stuff like Diablo and that, those demo blades, especially the tungsten carbide kind of ones, make sure you get them because the ones that are cheaper, yeah, you get more packs of them and stuff like that, but you'll wear them out so bloody quick. I probably pay like $80 for 4 or 5 of these. Like they're not cheap, but they last. I do a lot of, chopping bracketry off cars, and like especially this one here and everything else that I do. The amount that I use the Sawzall is actually a lot. It's a tank. I used to use a plasma cutter a lot to cut things off chassis and that, but it blows shit everywhere, it gets all over you, it makes the steel a little bit harder once you try and cut it again, and like, I don't know, I just don't rate it that much, unless it's some kind of real easy bracket to knock off. The Sawzall is just so good, you can run it along the chassis, and be careful, because if you do run an aggressive tooth, it will start to lead into the chassis, so don't take that into it, bury it in too much, but yeah, fantastic for doing that. If that doesn't work, we will run a clocked bracket assembly in here and try and chop off those wings. Just see how we go. I generally don't do casting and stuff like that in my bandsaw because I run a very fine tooth for stainless. And going back to like a carbon kind of tooth setup that's coarse, just annoying to swap it out. So we'll most likely just knock it off this. I might have to shoot into town and get some more blades. Look, along these videos and everything that I do, I will give you my thoughts on brands and stuff like that. I'll tell you right now, I'm barely sponsored by anyone. And the reason being for that is I like to self-promote myself. And look, I used to get a lot from Steal It and stuff like those kind of brands. And now I just basically back myself and do my own thing. And I don't really like to take on people's stuff. Look, if some company like 3M jumped on or something like that, yeah, I'd probably say yes. But most of the other shit that people throw at you, it's just junk. And I'm pretty, got a fair amount of integrity in myself, and I don't care for it. You know what I mean? Like, I'd rather just back myself and actually use products that work. So one that I do prefer is Diablo. Those blades are fantastic. They will cut through anything. They last long, and amazing for like Dana diffs when you're chopping off all that cast shit. So just a little bit there. That's a non-bias, like it's not driven by anything. It's just my thoughts on what I've used, and I do this a lot. And as I go through consumables and stuff like that, I will tell you what I do prefer, because I use a lot of different brands and I've come to a baseline of what I do like. So I'll quickly show you the diffs outside. I'll go for a little walk. I have another set here of the TTBs. See old Cruiser sitting there just doing nothing. But as you can see, that's our old assembly here. So that's the other Dana 44 TTB. Still all assembled and everything like that. Be mindful, like there's a lot of circlips and groove rings and everything in these. Get the proper tools to do it and take your time. Look at a disassembly kind of magazine to get them out and show you how to do it, because you will stuff these things up really easy. They're a bit intricate inside. But moving back to what we got to achieve, the casting will chop off, sort that out. The Brembo brakes are still on their way from America, so I can't do too much with that at the moment in assembling these. I would love to actually send these through with the studs, but I can't yet. The studs that I've got, the bit of walking at the moment, just sort of showing you some gear to get a bit of context. Where are we? Back here. I was just going through this yesterday. We've got like rebuild kits and all that kind of stuff, but these puppies. So these studs here are a 5/8 stud, very long too. But the actual backside of this, which is the lug nut, you can see it still runs that normal Acorn 22 taper on it, but they step out quite far, and I think that will look a real trick on it, especially being silver. On top of that, we do have these machine billet concentric hubs. Now, a lot of people get plastic ones of these with their rims for free. That's not the same kind of thing. These are a billet machined piece with retainers on it, and what the purpose of this is to basically align your wheel so it doesn't put pressure on the studs. You'll notice your rims don't actually have, one-to-one hole to match your stud. They're a little bit oversized, and the issue with that is that you can load your stud up and start prematurely fatiguing one of them. So it's a concentric hub. Basically, it will take the weight off it and alleviate that so that all the studs hold in evenly. It's the little things, I guess you could say. It's not everything you need. It's just things that, they're there for a reason. And if you're going to push the boundaries on stuff, all those little 1%ers actually help. Down here is sort of what the package is going to look like. So the method, you got your stud arrangement there and that section of the concentric hub. I personally reckon that looks very trick. The BFGs that we've got here are the 35s, and it kills me because they just look so small on this. It really deserves to have a 37 or a 39, but we just can't do it. And the other reason too is just because everyone in America runs those massive big tires, they're different kits. So this is a Bullnose Bronco. Bullnose Broncos have never been a very, what would you call it? used Bronco in America. A lot of brick nose and arrow nose kind of designs over there is what they run. And the benefits of that is that the actual guard arrangement and the flaring and all that kind of stuff, even like from Fiberworks and that, they're very proud and they've got a lot of scoop in them so you can run up travel. Bullnoses don't really do that. You can do it if you chop it, by all means, but you can see our side paneling lays quite flat. So look, we've got a 12-inch coilover in here, and we're probably going to be around that, I don't know, six up, 6 down. Maybe might chuck an inch maybe on the floor, a little bit more. But, you know, we haven't actually got a ton of travel in this. It's just going to be good how it works. And the valving that we'll do will be probably pretty heavy in this car. But the amount of travel that we have here, so like I would say it's probably about 7 inches or something. So the car at the moment is not sitting level because we're still on the 285s on the back. So we do need to bring it down a little bit and keep that height so it's flat. The height that it was at is what it's going to stay at, because the leaf pack that I've got coming to suit the travel in the back, it is for this height. So it has to stay at this. The up travel on this, honestly, if I can get it to run and cycle up to it just touches like half an inch here, happy days, I'll do that. If it doesn't, I'm probably going to skim this white back and make my own kind of fiberglass flare attachment. Look, I would like to have pumped flares, but not on the road. I want this car to be aesthetically pleasing and kept to its nature of being, you know, time period correct. And as it sits, that's what I really like. I think it looks it sounds pretty bent, but it looks elegant, you know what I mean? Like it's a time classic, and I think that looks really good. I don't want to go through and turn this into a Bronco that looks like a mess of fiberglass. So that's my sort of idea with this. I'm going to go through now and start chopping them out. Once I get them chopped out, I'll finish cleaning my spindles up a little bit more, and then I might paint them with Steelit and then chuck in the ball joints. So the ball joints I've got are like an unlimited ball joint. Where are they? I forget the branding of them, but they're pretty tank. These ones here. So I'll press them in, because once that's been painted, there's no reason why I can't. And then we can sort of leave them loosely mocked up on the actual beams, which would be good. It will start to show us what our camber looks like too, which would be nice to know. And that's the uniball assembly we have to weld in on the beams too, which that is what we'll do after we finish knocking these out. So I'm going to go through, get this ready, and then we'll have a look at doing these beams. Well, we're making some traction. So, and that's not a pun on the traction beams, but spindles and knuckles are pretty much prepped. Gone through, check the spindles themselves. Keep in mind, over the years along this kind of facing here, you want to make sure that it doesn't sort of dip or anything like that where the racers have eaten out or anything like that. Look, these are actually in pretty good nick, and the knuckles themselves, a little bit hard to get apart, but there was a fair amount of service that was done on these, which is great. All the bearings and racers and everything like that were actually pretty clean and nice, and everything else that followed with the locking hub, pretty good too. So, gone through and basically cut off all of our shit. That stuff that we were doing before, you can see here, that's all of the brake assembly stuff that's gone off it. And that Sawzall mint went straight through that really nice. Just when you are doing it, move back and forth along the blade. Don't just sit on one spot, and keep it at like a medium pace. Doesn't need to be red hot. Much the same as a hole saw. We don't want like crazy amount of heat on there, otherwise we'll diminish the tip, I guess. So at the moment, sort of just got the beams sitting there. And I just got the hubs on there just to sort of start packing stuff on, I guess, make some progress. They're not my major concern right now. My next concern is the back section here. So I don't think I've even talked about this yet, but there's a big chunk of billet there. These are my front radius arms. I'll have a little chat about them. Move this tire out of the way. Now, these radius arms are, once again, the same as the top, overkill. But like I said, I want to go all out with this build, and it's something that I cherish, and I like Billet too. A lot of people know that I make a lot of Billet products, so I thought, why not? This particular arm here, this is manufactured by Desolate. There is absolutely no reason for me to remanufacture this, and the biggest thing is I can't make it any cheaper than what they sell this. It's actually reasonably priced for what it is. My only concern is with this, and because of the design of the TTB, how it functions, it does run a back mount that has the articulation in it. The front section is actually fixed mount with a bolt. Now, I guess we keep design costs down with this, but if this was a solid axle, you'd rip all this shit off. You'd break these mounts. But because this independently moves as TTB, we can get away with the actual mount down here being a fixed mount with a bolt on it. So that mount there actually goes to the back of this diff. Because I've done the plating on this part, I can't locate the 5/8 hole. So what I have to do is I'll probably get a 5/8 washer, draw an X on it, and then try and transfer the actual X on the outside here with measurements, tack it, and then drill that hole so it chases in and doesn't bounce on the actual welding. And then we'll use that to actually locate this radius arm on. My concern that I was starting to talk about with these is that the back side of these runs a rod end. Now, obviously this is an Australian build, so we can't legally run rod ends. Like obviously there's this fixed mount down here and a rod end back here. We wouldn't be able to legally pass that. We need to have some form of insertion rubber or some kind of kinetic energy kind of thing to take that frequency, or whatever you want to call it, percussion away from the actual transfer back to the car. Now, there's a limiting factor with that. So, because this has such a massive roll axis in it, that's what stops this from actually binding down here and can let these beams travel what they do. And my dilemma is that obviously we need to change that. Look, you could run the risk, but look, I want it to be Mickey Mouse and no issues. So the only joint that I like is probably TMR's rod end. It's a polyurethane insertion around the actual yoke, so around the V-band sections of where that actually encapsulates inside the rod end. It will wear out quicker, yes, I know that, probably 6 months to a year. I'm not too fussed because they are rebuildable and cheap, but that's the only rod end I can see that will actually work with this design and have some form of actual rubber internals of it to pass engineering. So that's pretty much where I'm going to go. Lucky these are 1.25 inches, so rod ends just go straight into it. Happy days. Yeah, and these assemblies here are not as easy as like Patrol and Land Cruisers with your kingpins. 4 bolts, you chop them off, easy go. And also too, the other thing too is most of them, they're nearly so worn out, they're not even a press fit on the actual bearing. With these, holy hell, these were an absolute nightmare. You can see in here, that little ball joint, they actually press inside, if you can see just there. And this one runs a circlip on the bottom. My concern is that this one doesn't have a circlip. The one I took out didn't have a circlip. I physically can't press them any further. So I need to do some research and actually make sure that there is a potential for a circlip to go on there. Otherwise, we're just going to have to run it how it is because it's spline indexed in and doesn't move. So one thing to take consideration there. The next, moving on from this, is obviously we got a billet adapter to go on here to pick up our Brembo brake assembly, which is going to be over here. Our rotors are going to be like 14 to 12 inch rotors. The top section here, we do need to get an internal section for this ball joint to pick up. They do have a camber, a camber alignment that goes in there, a little puck, pinches, and you rotate that around, which gives you increased camber. You can get up to about 2 degrees, I believe, with internal of that. I'm going to order new stuff. The stuff that come out was janky, and my TTBs actually have miscellaneous bolts and nuts, different sizes. So I'm going to go back to basics and order a full brand new kit to do all that. Building onto this, I've already got the Tinkman assembly for the wheel bearings, so to pack all that out and get that going. And then the last section is worn free locking hubs. I won't be using my hubs. I want to make them nice warm ones. And yeah, that's sort of where we are at with that front section now. So you can see here, obviously the alignment is not going to be perfect with our actual camber at the moment with this, but once we start to get it all bolted in and everything like that, and the actual ball joints pick up in their taper lock, then we'll really be able to see where this is sitting at. But at the moment, we're looking all right. If we do have any more issues, we're going to have to cut and turn these, which means we're going to have to chop the lower ball joint section out, probably going to have to throw those ball joints in the bin, and we're going to have to push these out to get more camber. Ideally, for a truck like this on the road at ride height, we want about 2 degrees of camber in this, negative, which means your tyres are going to be on a lean, pointing inwards. You would run more to 4 to 5 or so, even higher, if you were running this in the desert. And the reason being is as these beams droop down, we want to stay within that negative to 0 degree of camber. As soon as we start going into the positives, that's where we cause a lot of issues. Now, my suspension, it probably will see that, just physically due to the demands of what I'm doing with this. I probably won't be able to get it Mickey Mouse, but if you were setting this up for racing, that is something to consider. And also your contact patch engagement of your tyre and how that all lands and everything like that is very critical, and especially how you do your turning too. So if this is sitting as like a positive camber, you're going to have issues with your steering, and as that goes through its geometry and stuff, how that changes. Just food for thought there. Look, we can only push this so far, like I said, but I'll try my best to try and get the race kind of aspects to it. Also too, we don't want to be driving around on massive negative camber because we will wear these tyres out. They're not cheap, and this is going to be my daily. So bit of food for thought there to take in. Now that we've done this part, we'll go back to the beams now. So now I want to get back onto the uniball assembly, and I actually want to start getting to the point where these shocks are actually physically tied in and those radius arms on. So that's something where I'll be basically talking about next through this kind of segment. As for the back here, if you can see this, worked our way down the chassis. It's got bolt-in brackets, and all these brackets would be welded in. It's basically just for alignment at the moment for myself. This is sold as a bolt-in kit, so you could definitely run it as is, but I would rather weld it in, and the engineer's happy with that. It does have a 70-75 cross brace here, which actually ties those brackets in. Because it's bolt-in and all that kind of stuff in a C chassis, I'd say that was put in purely for flexing of this actual chassis and strengthening it. You are starting to put a lot of inertia through this kind of car and twisting and torsion. Now, when I actually did this, if we can get over here and try and come under. Ugh. When I did this, you can see this bracket here. It did flare off the chassis and anything like that, so I found one hole of the alignment that they do recommend. I put that one hole in, and then the rest you have to drill. So basically I did it up tight, the one in the bottom, and then I used a G-clamp to pull it in, and then I drilled it all out. The chassis steel in this is quite tough. It's obviously like a spring steel or something. So cobalt drill bits is your friend. If you are trying to find a center point on this, use the drill bit that you're going to drill it out with to create that where it actually tapers into the drill bit. And what I mean is like where your heliax comes up and then tapers into that 120 degree of your actual drill bit. The point of that, if you have to drill a 1/2 inch hole, start drilling the 1/2 inch hole, and the tip of that will create the center point within that actual hole of the bracket, instead of trying to hole punch something that has no reference within there. You could use a transfer punch, which is 1/2 inch with a little tip on it. If you don't have that, just use the drill bit. Works pretty good. So I'm going to go through and pull these TTBs out and get them all prepped up to start doing the next jobs on them. So as we work on the Bronco, there's obviously going to be a lot of stuff in the background that I do too, and through videos, I'm just going to bring it up and show you that because these are more vlog style now. And this is a pretty substantial one. This is a very, very cool project I've been working on for about 8 months now in the background. And it's a 70-75 billet trailing arm. So this assembly here is pretty substantial in design, especially from the artistic perspective of how much has been implemented into it. And I thought, you know, it'd be cool to sort of highlight some things quickly to you, application of it, materials and some ideas. I'm just going to beam through it pretty quick and sort of give you that overview of the whole purpose of this. So let's talk about concept. Concept for these is more like a trophy truck, okay? What we're trying to do is basically create a motion ratio of our shocks. So instead of having, you've got our chassis mount here, our diff end here. Instead of having our shocks mounted here, the further we move them up, we create a motion ratio, which is going to give us more droop over distance without having shocks so big to do that. So traditionally, you might mount a shock on the back or a coilover on the back of that diff. it's a 1-to-1 ratio really. Over that distance of that cycling suspension, if you have an 18-inch shock, you're gonna have an 18 inches of travel, basically, give or take. With this, we move it up, we get a motion ratio. So we could go like a 2-to-1 factor, and we could have a 12-inch shock that might see 22, 24 inches down the bottom side of it, which is pretty substantial. Obviously, that changes a lot of stuff when it comes to the actual shocks themselves and how they're tuned and the frequency of it too. And that's something that you need a really good shock tuner to actually identify and set this up for you, because you can create a lot of problems with that. And that's where you're going to come down to, this is purposely built for expensive shocks. Shocks that have that tunability in them, and that's what you need to sort of factor in if you're doing something like this. In most circumstances, if you were to have this in a trophy truck or something like that, you would probably see, you know, like a 3.0 coilover and a 4.5 Kings, you know, quintuplet or something like that, or multiple tubes all over it. So a bit of food for thought there. And like I said, that's basically the design of these is what that gains, is that overall droop, and that helps you get massive suspension cycle, which takes up the whoops basically. In a rock crawling world, these are starting to come into it, but more in a low grade option. We're talking like mild steel arms, and most people are opting for above than below. So these are a lower trailing arm, people making above ones, which keeps that off the ground, and obviously your suspension's up a bit higher. Really depends how you do it, because that design can have other issues with it. You do have roll axis in your actual thing, which means you need anti-wobbles. And also too, I guess you are putting potentially weight higher in your center of gravity, depending how much that actually is and what you're doing. There's a bit of food for thought there, but a lot of Ultra 4s have opted that way. Very successful Ultra 4s too. So definitely a pretty cool concept. Now, the actual design of this, we'll talk through it quickly and just call out some things. So we've got a uniball up here with an internal cup section, which has got milled in circlip, which is 68 mil. Moving down here, we've got 2 tabs that protrude through the actual body. They pick up the skid plate on the bottom, which I'll show you in a second. This section here is our bucket. This is where our shock package picks up. Pretty significant how much is involved with this. One, you need to account for the swing of that actual shock assembly and what it does through its motion. We also need to account for debris and build up and sediment and stuff that sits in these buckets. If you care that much and don't clean them enough, I guess you want some runoff to it. We do have 2 holes that protrude through that to let sediment out. We do have a section which comes up inside the profile. So if we have our thing, imagine a W basically, it comes down, rolls back up, and then that's where our swing set of our suspension is in. That center section has a bolt that drives down, picks up a 19.9 mil spigot, and that pulls the skid plate back in. The reason for this design is to eliminate how many holes we have over distance, and having like blind bolts on the bottom that get chipped and knocked that you can't get them out. Aluminium is not, you know, the easiest thing to repair and stuff like that, and this is not weldable, so we want to reduce, if things happen, what we have to do, and that's the factor for that, is that we make stuff that's sort of hidden, recessed, and it's not going to get damaged from what we're doing with it. The bolt assembly, all the bolts through this are a 12.9 grade, and they're 12 points, so like, you know, the head's orientation. Extremely strong, like 3 times stronger than your normal bolts. So massive gain over that. Internal of this whole profile, we do have 17.4 inserts. 17.4 is a stainless grade, and it is corrosion resistive. Also, it is a very high tensile steel, which is going to help with the bolts wearing on it before it wears on the aluminium. And that is the purpose of inserts on stuff like this. Moving back, we have a key weighed notch section, which has 2 bolts that retain through at 12 mil, and they pick up this triple limit strap assembly. And then moving down from that, we have a retained Durameter bush section down here with a 58 mil circlip groove. And that's pretty much the overall design of this. And underneath, we have a skid plate, which has been milled into it. That's a 304 grade stainless skid plate. And that assembly has got the spigot and then the 2 blind recesses that come through. It has been pressed at 1 degree over each side so that when it pulls up, it tensions. Really limits how many bolts we need to have in this, and the sacrificial chance, like, you know, the chance that we do derate the actual integrity of this. So that's pretty much the design of it. When we talk about the strength of it, it's phenomenal. These arms can exert a lot. And obviously being 70-75, it will bend, but it bends back. So there's a form of like deforming ratio that we'll see through it, and that would be like massive load of jumping. But that's the purpose of 70-75. It's not like metal where the malleability of it retains from that the deformation from it. So something to take into that consideration there. But these are a very substantial arm. They do sit at plus 40 kilos of aluminium, which is pretty crazy. And they're very big. It's hard to put in perspective, but you know, these are like 1200 plus mil long. These are very big arms, and they should do a pretty nice job on them. In terms of the shocks, the inserts that you'll see on top of these 2-inch rod ends, the 2-inch rod ends obviously get your shocks out of the bucket. The reasoning for the bucket and the way that this is set up is like a canoe style. Canoe style basically is going to help with that roll axis. So those arms, obviously, you got eye to eye, and if you mount your shocks below eye to eye center line, you'll actually sort of combat that roll within the arm. If you do mount them above, you have to do something to counteract that, which is going to be like an anti-wobble bush or something like that. It does make the arms a lot bigger and beefier, obviously, because you're trying to counteract that. But this is a pretty generic trophy truck design that's been around for many years. A lot of people flirt with different ideas and different materials. But I want this to be as safe as it possibly can, and we do have a very high safety factor with these, which is pretty crazy. Looking at jumping this car fully loaded, you're looking at about 2.5, 2.4 safety factor, which is up there. That's like near military shit, basically. And obviously the material this is used in, it's not 60-61, it's 70-75. So a lot dearer, but the intensity of that strength is double in terms of tensile strength. So very, very cool. And it's basically just being coated with a 2K, and that seals up the aluminium. You'd probably have to re-clear them every year, I'd say, if it starts to tarnish and perish. But yeah, it's sandable. You just sand the aluminium if you want, get abnormalities out of it and clear it again. You could go Cerakoting, which is a new form of kind of clearing and stuff. But the price perspective and how long it lasts, I've been told by many that it's not really worth it, to tell you the truth. It's cool on shocks when they come brand new, but other than that, 2K clear is pretty cheap. Does the job. So that's pretty much the design of it, and it's pretty crazy to design in my head. For 8 months and to see this in front of me is very cool. I didn't think that this sort of would kick off and actually happen. I was a little bit worried about it, but we eventually got there in the end and committed to it. And here they are, assembled, done, ready to go into a car, which is crazy because most companies are a R&D platform of designing something. So like if I was to design this and do it again, I would chop this down here and only have that milled and made so that I know that that front section's perfect. You can't really do that when these are one-offs because it's an exponential price that rises on this stuff. So it's just a one-off wonder, and every single thing on it worked one-off. And for people to understand how much of a significant risk that is, it's massive, and they worked. I'm super chuffed. Every single thing on this is amazing. So thought I'd just pass that on through the video and give you a bit of insight to just before they go into the vehicle that they're going into. And yeah, anyway, we'll get back into the Bronco. So I've ripped out the TTBs and we're just laying them out now to try and figure out how we're going to tackle this, because it's a bit of a interesting kind of one to try and scallop these in. There's no real like reference of it, just sort of people do it how they interpretate, sort of combining that uniball into that assembly. I popped off the bushes, the back section here you can see, pretty easy to knock out of the socket or something like that, just like crush tube in the center, boom, straight out. And then now we're replacing that bush with this uniball. The beauty of this uniball is a lot more serviceable and easy to sort of just pop a uniball in and out of the circlip. And also too, the actual alignment of our caster down the bottom here, we can tweak this a little bit and put a bit of clock in it to get a bit of gain in that if we can. That's really dependent too on our radius arms because they are a fixed mount, so we'll see how that lines up. Now, the back section of this, so I've already braced these up myself. This is something I just put on CAD and knocked up for it, but the back section here, we need to account for this uniball cup going in here. And judging by what we can sort of achieve here, I don't know if it's worth raw dogging it or if we actually try and scallop it. Because what I've seen in most people's circumstances is the back section of this, they literally just chop this front section off and that uniball becomes the new section. There's a little bit of a back strap on this, and I was thinking about cutting out like a CNC infill with a 6mm hole, tacking it in, and then sending the hole saw down, and then die grinding the internal to try and suit. And then that way we can sort of slip this in and pick up that back strap. But is it worth it? Might not be. I'm just going to figure that out now and try and see which way we tackle it, because another thing you can do with these is just backstrap it yourself. So obviously just top section and bottom section here. There's nothing stopping us from just getting a bit of strap, putting it over and tying that in. So it might just be easier to cut this out with a grinder and just try and graft it in. My only concern now is obviously the alignment of these. So because we're not just dealing with like a nice diff where you just got fixed mounts and it sort of parallel tracks easy and that kind of stuff, we're dealing with so many, points of pivot. We've got the two on here like this, and then we've got the radius arms like this. So you're trying to kind of like combat this. It's a lot of thises, but I'm trying to get the alignment so it's pretty good so that we're not, putting bind into a uni for no reason. And if we are trying to get caster, we could start exceeding it a little bit too much. You don't really want these working out of their like static range, because then you start to wear them out a bit more. And the more you deviate them, the more they get sloppy and stuff like that. So I'll work that out. And then the solution I come up with, I'll pass on sort of reason why I did it, and then we'll try and get them in. I'll probably TIG them on, to be honest. We'll have to chuck a brass bushing in this to stop it from deforming and just retain it in there, and then while we weld this out. Root pass, get it all in there, nice, and then we'll do a cover. And then that should be pretty good. Once we've got these uniballs in there, we're really starting to knock down how much left we've got to do on these. And that sort of ties us into the last two portions of that, which is going to be coilover brackets, which are going to be pretty easy to get done, and then the radius arm brackets, which we just got to knock out 258 holes, locate it, and get that caster, and then we can tack them on. Once these are all pretty much at the point now where as soon as that's done, we can like coat these all and steel it, get them under there, and now we're cycling. And that's sort of my focus at the moment. Get that front end cycling. I've got the Wilwoods brakes. They're just about to hit down. So I'll get the brackets on there, get them on, and then we can put our snout blocks back on. And we should have contactor tires on the ground to sort of wheel this around again. And that's sort of where I want to get to. And that's my main focus at the moment. And then we can move on to sort of the Hemi and strip it down and, address if this is going to work. We have about 30 mil either side, give or take. So anyway, I'll pop through this, get the uniballs in, and we'll start assembling. So I decided to go through and actually make up some tiny little radius plates, and these are going to go inside. We'll lift this. I've got a socket in here at the moment, and as we lift that up, it's obviously going to guide us. We'll get a tack one side, and then we'll just use a piece of flat to try and get our levelness on that. It's only a 6mm hole and 6mm plate, so it's really guided down to how well I am hole sawing over distance for that hole not to elongate. I don't want to put a puck in there that's like 30mm thick or something like that. So if you had other equipment, you could do this a lot easier with fixtures and overhead milling and stuff like that. But this is a quick little thing. In saying that, if you really struggled and you couldn't, obviously plasma up like I did, you could just get a hole saw, 42mm hole saw or something, and try and find something, maybe Imperial, to find that hole, and you could just cut that out of the hole saw and then put the hole saw puck inside there, and that gives you the next portion to hole saw it out with the bigger one as we lead that through. So I've got the welder set up now. I'm going to be pretty rude with it. I don't need to be super critical with these. It is a very big articulating joint, so don't feel like it needs to be perfect, but once we get it all in, we can actually fix that up. So we're going to lift this up now, and this side here is sitting pretty good. Get that reasonably where we want it. That's pretty good. Wire speed's a bit up there, so I'll come back and get that off. But now that we've got that there, I'm going to tap this out and we'll slowly... So now we're hitting across the other face. So I'm pretty happy with that as a guide. And that should be good for us. Could be struggling a little bit with the earth too. We've got a bit of a mat here at the moment. Got one more just so. So I'm pretty bad for tacking with no helmet, and generally it looks like I've been to Ibiza for 4 weeks because I go to pub or something and I got the brightest red face. But it's just easier than having a massive big helmet on and doing stuff like this. So now I'll get that arbor in here, and that's looking pretty juicy. We're probably going to take about 2 mil out of this back strap here, which is all good. And then that will lead us in. Once we get that all sweet, get that cup, we'll just die grind dress it. It's going to be about 1 mil under because it's going to be like an imperial size. It's like a, whatever it is, 42, something like that. And once we get that in there, I'll show you the puck. So moving forward, we've actually had pretty good success with this hole saw setup. Definitely going to wear it out. These being just a Sutton hole saw, I just had it laying around. They don't really last too long. If you went up to like a Lennox or something like that, or Milwaukee's not too bad too, but the better brands will last themselves. But you see this, the Suttons, they start to break down on the teeth. They're not that fantastic. Good for plastic and mild steel like sheet metal. But I'd probably say you'd see 2 cuts out of this and that hole saw would be useless. And that's all I need, is 2 cuts to get these out, which should be good. In terms of this puck section that we put in, worked an absolute treat. And the bracket that I made here was actually good because it pretty much took off like 0.5 mil off the outside of this. So the design in CAD and how it's fixed on here and everything like that worked out pretty good. So I'm happy with that. This is a monstrosity of what come out of that. So that's the original bush cup. And that's where you would see that rubber here get pressed inside there like that, like a crush tube. Much the same as a leaf spring hanger kind of setup. So that worked really well. I was happy with that. And like I said, you can just use a hole saw to create that puck and then use a bigger hole saw to cut. You don't have to have a plasma CNC setup. So that uniball cup's in there now. I just started to go through and feather it out, chamfer it with a die grinder and get it ready. Now, this is a very important part. You're welding something that's concentrically round, and the fitment of that is very crucial for a uniball to actually seat in there. This is a bronze or brass or whatever you want to call it, uniball puck. It goes in there pretty much, it's a replica of the uniball itself, like this one. And pretty much it will sit in there. It will help absorb the heat, and also it will stop the cup from distorting basically. Look, if you buried your TIG welder on this and just did passes after passes, you're probably still going to warp it. It can only do so much. But look, honestly, a good root around this, like tack it heavily, and then a good root one side, let it cool for 5, the other side, let it cool for 5, and then do your passes and stuff, you'll be all right. If you just go to town on this, it will probably distort, and you'll probably be smacking this or pressing this home. And that's not really something you want to be doing. The fitment's crucial on these. They are a spherical kind of bearing setup, and they don't like to be hit home. So pretty happy. That this is the first time I've done one of these rod end sides on a TTB, so it come out perfect. I just got to duplicate that on that side there now, and I'll get set up on the TIG, and I'll go through a couple of settings and sort of show you as I beam through that. We're up to the part of welding now. So I've got these cups sitting in there, and I've actually knocked them into their alignment kind of area, if you can see. They're sitting pretty good. The actual strapping of this is a kind of an elongated path as it goes around, so don't be misled by how it sort of looks. It sits flush with the actual design of what we're doing here on these arms. We'll go focus on this one first, the puck. That bronze puck's in there to stop that distortion of the cup as we weld it, so that we can keep that parallel fit as we put our uniball in there afterwards. It can only do so much, so don't go there boiling the hell out of this and just go full town on it. You know, go let it cool down a little bit and do its thing. As for the welding, we've tacked it in with the MIG welder over there, and now we're going to go through and do some passing. So we'll do a root pass with 1.6 ERS 70-6. Good rod, very robust and good for putting dissimilar metals together, like 4130 and stuff like that. It does have a little bit of a silicon kind of debris that builds up on it, so as long as you weld it and swell that out, you're all sweet, so then you don't leave any kind of inclusions there. So we'll go through root pass over 1.6 rod, and then we'll cap it with a 2.4, and probably just like pulse 2.4, jam it in there and get a nice cap around it. Rods there, and as for tungsten, I use a multi-mix. Go from weldporn.com. Multi-mixes are good because we can use it on various metals instead of just having the basic ones like 48 and all that kind of stuff like that to do different metals. I'm pretty robust with what I do all the time, switching between alloys and metals and all that kind of stuff. So these are really good for me, and I use a 2.4 or a 332s. And we went through, acetoned it, and then hit it with a bit of heat. So just before I go to put this in and weld it, I'll hit it with a little bit of heat to get the steel just up to reasonable temperature. It's like 4 degrees in Orange at the moment and ice outside, so it's bloody cold. Even the camera's struggling to engage. So bit of heat there to get that metal up. A little bit too is like a lot of people heat the hell out of steel thinking, oh, all this water's coming out of it. Look into it. It's actually a hydrocarbon burn off that you're doing. So it's a bit of science behind it, but you will get, you know, a little bit of moisture out of it and get nice, but a lot of the time you're actually producing water, so don't sit there and just boil the hell out of it for no reason. Yeah, so I'll shoot into the helmet on and we'll start blasting this out. Alright, so I'm going to go through and tack this up now. Still got on the 130 amps, and we've preheated it a bit. Just lay a big juicy tack in there. Sweet. Lay one on this side here, and then I'll flip it over and we'll be able to start doing a bit of a root pass. So the post gas is about 6 seconds at the moment, which is pretty excessive for mild steel, but I want it to look pretty. So flip that over. Now one thing I noticed I've got to be a little bit careful is on the other side, where that cup is being welded sort of on the C-clip groove. I've got to make sure that I don't distort it too bad. And the tungsten I'm just running at 30 degrees. Pretty generic. Sweet. So now I go through and root pass it that we've locked that in. Probably just do 50% of each side, so that we don't go to town too much. As we know, radiuses are pretty hard, so you don't want to, as you start moving around, we don't want to flare that envelope out too much. So just reset yourself. And sort of get back into it so you don't have to generate too much heat again too. So we're hitting that mild steel tack now, so it's going to flare up a little bit because of the impurities created from that. And yeah, we'll go through and I'll weld them out, and then we'll start setting up the uniballs in them. So after welding those uniballs out, pretty good success on them. They didn't distort at all. The brass puck done its job. I naturally let it cool down for about 10 minutes, which is what you want to do so it can, sort of relieve itself and, go back to its form on the contraction. And pretty well, the brass puck, I just hit it with an air buoy, cooled it down in the center, and then the puck eventually just popped straight out, which is awesome. And now we've got them in. So the bottom of these brackets here, I had to get a pry bar and flare them open a little bit just because they suit the original bushing. But they're all good. They're scoring in there. And currently, I've got the radius arm brackets on the back tacked on. So I'll show you what I've done. But basically, the 5/8 hole that we were talking about originally in the video, because I had fish plated that with that X bracket, we lost the 5/8 hole. So all I had to do was measure it up from the back, put that on the front, drill it out. I chased it a little bit with a die grinder to find out where it naturally sat because I didn't weld it completely out. And then once I found that section where the 5/8 hole originally is, the drill bit just naturally wanted to go through that, which got us pretty well. And my concern is basically as these sit, statically on a horizontal line, I don't really want the radius arms on the back to have any weird clocking or anything in them. I want them to sit exactly how they are with each other. And that's how we are sitting currently, so they're pretty good. Pretty much just, bold them on, and where your actual C or knuckle section is, I pretty well just got them level with that because that naturally sits horizontal and we just want the arms to sit true to that. So as they dip down, the back side of the rod end area is pretty good now where it cycles. So we are pretty good now in where we're sitting. We'll have to find ride height and then start cycling and then working out bump and shock and all that kind of stuff. The last thing we sort of have to do is the brackets for the suspension. We do need to get them out sort of as far as we can because we are running a 3.0 and the coil is quite big. But we do need to factor in that we are running a 0 offset rim. So it's going to be very tight packaging, and hopefully through its cycling range we don't touch coil on chassis. Can only do what we can do. If we have to modify the top and bring them out a bit, so be it. I'm trying to avoid it, but we'll just see how it lands when we cycle. And we've got our hubs on it. We chopped the casting off the back, which is going to suit that Wilwoods brake kit that's coming. That hits in about 2 days. It's just cleared customs. So we'll be able to bolt that on, and then we'll be able to get our hub back on and start to have tyres on the ground, which I'm pretty happy with because, honestly, I would say this is the biggest part of this whole build. After that, we're going to be pretty smooth sailing through things. The amount of suspension in the front of these is tricky, and getting it to work completely in its package. And I am not extending anything. I'm not extending beams. I'm not doing that kind of stuff. So I have a very limited space to deal with versus what an American person would do with their build. It's very open. But as we move down the car, everything starts to get progressively easy. You know what I mean? Like the rear diff, stuff like that. It's not massive moving parts like this. And yeah, I'm very happy with the outcome so far. Like I've put a fair amount of time into trying to make this nice and clean and weld it out and stuff like that. Most people know that when you build for yourself versus customers, you put a lot of time and effort into customers' stuff because it's your name on the line. When you build for yourself, you're like, I just got to get it done. I did try to balance that out and spend as much time as still to put this as a showcase of what I can do. And I'm very happy with it. The welding and stuff like that's pretty nice. And once it's all painted up, it should look pretty trick. So now we'll go through and get these shock mounts done. This side's going to be easy. A little bit of, just scalloping of the bracket to get it close to the housing. This side's not going to be easy because we have our bracing here. How I'm looking at that is, I don't know if we chop the bracket or we chop the bracing, but I'll pull it out and we'll chuck it on the table once I mark it up. I'm pretty much just going to set this side first on drivers because there's nothing there, and this will dictate what the other side does. So that'd be pretty good. Yeah, very, very happy with how it's all looking. And we just sort of got to go through and notch this out here for our pitman arm. And then we'll chuck on our drop pitman arm, which is going to help a dramatic amount of steering, bump stop, like bump steer and all that kind of stuff as we flip everything and change the trajectory lines as we go out to the outriggers on the side here. So we'll have a quick look around with the camera and I'll show you some key areas and stuff. And there's also something I've picked up on this actual strapping on the front, which is going to hit on cycling. So looking from the back of the beams, this is where our radius arm sits in, and you can see I've got this tacked in here at the moment. I'll flip this light around for us so you can see. And you can see there where they're sort of sitting. And this is that fixed bolt that I'm talking about. I'm not a massive fan of it, but if we have to change something down the line, we can. We'll just see how it all goes. It's because the pivot point is on the back here, it has that roll axis in it, which can handle it. But it'd just be nice to have some more bushing down here, I think. Now, as for trajectory on our beams, they're working and cycling and everything like that in its area. My only concern is it's going to be the CV that runs across to driver's side and it's clearancing. We're going to have to chop some bolts down and keep them pretty snug to the frame. And the other thing too is the other side is the strapping that we were talking about. So that front strapping here, we're going to have to notch a little bit. So if you can sort of see it, get the camera in here. Whoa. There we go. So that little section there, it's very close, but I'm just going to notch it out. So we'll have like a little step down, and that's sort of like what you do on cross braces when you do you know, patrols and you want the tail shaft to sort of not foul on the cross brace. I'll just do a little step in bracket there and notch it in a little bit. And, you know, basically a mill's a mile. So if it cycles and we're all good and locked out here with the radius arm, we should be all good. So that's something I'm going to focus on, and these shocks, and we'll get it cycling, and it should be nice to see these drop down the ground and start looking at the actual the camber curve. So as this actually goes down, I want to find out where that camber is looking at, especially ride height. I definitely want it to be in the negative on ride height. And like I said in the previous part of the video, we're going to see positive probably in this just because we can't run too excessive on the camber, but we'll see how it all looks. I've gone through, done a little bit of temporary mocking up for these shocks. Chucked a 2.5 inch coilover coil on there, which is a 3 inch OD. We're going to be a bit bigger on our ones once we order them, but I don't have Frio coils on hand, so it is what it is. Gone through, sort of mimicked up that tyre. It's just off the ground at the moment to sort of get that snout spindle in the center point of that roughly, and I've measured a back spacing from just a point of reference, so top of this knuckle here to the back side of that facing on the rim, it sits about 90 mil, which would give you your mounting surface or wheel mount surface. And I've sort of just brought that wheel in like to 85. Give us a little bit more of a, you know, not building to the mill. So the bracket that we got here, where it wants to sit, is sort of pretty much true there. That's sort of like, I guess, where it sort of naturally wants to fall with the cuts in it. I want to bring it a bit further out on the beam, so I'm probably going to notch a bit of the backside of the bracket and bring it up just a little bit. So you can see our gapping in there now. It's not horrible, but because this is a different delivery and the notchings and all that stuff on the chassis for an Australian, I'm a bit worried about where this is going to like swing ranges. Obviously, as this tips down, it's going to fall backwards. So technically, we should be pretty good, but there's no reason why we can't bring this a little bit more out. And we'll take it sort of up to the point of that knuckle section, or the C. And we'll have to try and, what do you call it, marry that in and just put some texture marks on there and flap it in. I'll MIG this in just so we can get that gap. TIGging that would just be a nightmare. You'd be weaving the hell out of it and trying to put massive big welds on there for no reason. So that can just be MIGged on. And that's going to be a big step for us because once we drop these down, that's going to look awesome, and I'm pretty excited to see this happen. It's something I've been building up towards, and there's a lot of work, like just with everything I've been doing with cleaning and all that kind of stuff. You don't see the progress. You're just constantly doing the small little things. So this is sort of one of those, you know, dopamine, serotonin kind of things where it keeps you going, I guess. Right, I'll lay some texture marks on that and graph these in. I'm only going to tack them. Everything on these diffs is sort of just tacked in terms of bracketry. And once we're really happy with it, that's when we'll go through and blast them in and then hit it with Steelit. Brake lines too, I'm not going to do what they do normally with the brake lines drooping out. Much the same as Hiluxes. Hiluxes have the brake line bulkhead, top of chassis here or bottom, and then they have a big massive stainless hose going down. I just think it opens you up for getting caught out and catches on them and stuff like that. What I'm going to do is actually run lines down the beams each side from the back side of this bulkhead, and then do small little jumpers out to our Wilwoods. I just think it'd be a lot nicer. Probably do stainless lines, or we may just do flex. We'll see what it looks like. But the braided flex over that distance really is not that bad. It's not going to expand and bloat up and all that kind of stuff if you use a good line. There's many people that run trophy trucks with the whole rear diff being a braid instead of having stainless lines everywhere. Also easy to replace if you just make like that length there and that length there. Keep on in the car if you damage it. All you have to do is just throw the line in instead of trying to, you know, pinch the line off and lock it out. So yeah, we'll lay some texture down and graft them puppies in. So I've gone through and pretty much grafted in to account for our bracing on the front section here. Look, obviously being the MIG, we'll be able to fix up some kind of gapping in that, which is all good. But what we're going to do now is go in here, and because these new style have a bit of a O-ring in them, they're a bit of a squish down, if that makes sense. The original ones weren't sort of like that. Line that hole up a little bit there. And then that's us there. So now, go through and attack that puppy. Now, chuck some gloves on, because we want to burn those little precious fingers. And we'll go through here now. And like I said, we basically just want it out as far as possible, and this one will set what the other side does. And this is the beauty of this kind of, and you can see this kind of notch here which kicks off for our outer C here. But the beauty of this kind of stuff is, as long as you're symmetrical and you push everything out as far as you sort of can, you're not going to have too many issues in the actual alignment of everything like that. It's not super crucial where like one side of the packaging is. It's just as long as it's the same on the other side. I say that within reason, obviously. I am still accounting for a fair amount here. But that there, I like a lot. So, watch your eyes. Ooh, we got a bit of slip there, a little bit slippy. Actually, we're going to attack the top side. Let's not stuff around here. Eyes. All right. So now, also too, when you do tack, don't tack in spots that are hard to crack or get off. If I had to get rid of this bracket, there's no point putting a big juicy tack in here, because I'm going to struggle to get a grinder in there. So I'm actually pretty happy how that's sitting. My only thing I'd like to do is get a little bit more twist in it here. We'll get a tack up here. Just set that back section, eyes. Yep. And then now, we'll get one on the bottom. Down here looks pretty good. I have to weave it a little bit as we tack it, because it's got a bit step away. Yep, quick little whoop. A little bit more. Whoop. All right, that's us on. Now, obviously, we're probably getting ahead of ourselves here, but my curiosity is killing me. So, let's... Yeah! Stop it. Could you be any more fucking sexy? Look at that. That is... I'm pretty happy with that. So you can see already, that's definitely going to give us some positive camber there. So if we have to do the cut and turn and pull these out, so be it. But look, we were always expecting to see something like that. To try and keep it zero, we'd have to drive around a bloody massive neg camber. But we'll come back to that when we start to care about the geometry of our camber. But so far, I'm obviously got no nitrogen in these. Yeah. And that's going to reach our top hat there because this coil's too long. These are for 16s, not small little 12s. But, baby, couldn't ask for much more than that. And obviously, because we're running internal bypasses on the front here, we do want to have this in the range of floating in that midpoint. We don't just want to have all this droop and no up travel. I want this to absorb. So that's something we'll have to get on there. I'll probably knock this off now, and we don't really need to coil anymore because we've worked out that the swing ratio of all this stuff is pretty good, and we'll be able to see a bit more compression in it. But I'm going to go through, get the other side ready, and then we'll see where we're up to. Well, guys, that brings us to the end of another episode. We have made significant progress in this one. As you can see, we've got the TTBs completely in now. Done a bit of notching in here to account for the actual compression. We've got our full knuckles on. We've got our billet adapters, our massive big disc brake. We've got our Wilwoods that are on there now. We've got 5/8 studs. We've got our massive big oversized wheel nuts, concentric hubs on there, and we've also got our worn locking hub with all brand new gear all the way through. Shocks are completely in now and tacked into place. Cycling, radius arms are tacked into place and clocked and symmetrically aligned. And pretty much I would call this front end ready to complete. It is cycling beautifully. Obviously, it'd be nice to have that big travel, but for what we're doing with this car and being on the streets and the road and engineering and stuff like that, we've got to be mindful. You can only push things so far, and I don't want this thing to be a massive, big suspension pig. This is going to be my daily driver, so I don't need to have, you know, something like 20 inches of travel on the front. But what we've got here is pretty, you know, mild, I would say. But it's very good quality gear, and that's the highlight that I want to put here. Everything I'm doing on this is up near the highest of grade you can sort of do before you go into ridiculous, you know, 4130 or 4140 chromo stuff. We're not talking about, you know, aftermarket hubs and stuff like that, and knuckles and all that shit. In its form that we have here, I would say this is the best you can do in a Bronco TTB, factory length TTBs or beams. So pretty happy with it. This is sort of a big thing for myself because I love a lot of American trucks. You know, I love going over to America, and this is sort of that kind of thing where I get to have a bit of that American dream back over here. I know it's not for everyone, but for me, this is pretty significant in what it actually is. And there's a lot of, you know, time, effort, and money going into this. And, you know, it's just something pretty big to take on for myself, considering everything else I've got in the background. But we will keep going on with it. And basically, at the moment, I'm just waiting for some cam internals to go on to the knuckle here for the ball joint. Just to sort of get about 2 degrees more camber, negative. And if we can achieve that, we don't have to cut and turn these beams, which would be awesome. So hoping for that. And then basically, as we go on to the next episode now, I've cleared out the sides here, taken the fenders off, everything like that. So we're pushing towards the engine. Next episode, we're going to strip down the engine, talk about what we're sort of taking off it, how we're going to hook it up, basically lift it up and scan it. We're then going to scan this, and then we're going to bring it over here and sort of get it in here and hold it above to get references of how it looks in there. And then we're going to start drawing up some brackets and CAD. We'll get all those mounts made, and then we should have an engine plonked in here, which is going to be awesome. Still on the fence a little bit about the transmission. I still want to stick with 8 HP, but I'm thinking about swapping to a 4-wheel drive Cherokee one, knocking off the active transfer case on the back, and then adapting with an 8 HP down to a 32 spline NP205 coupling, and then running a Colossus DIY box with my 205 gears, which will give us a left-hand drop, very bulletproof assembly, but very short in its actual design, which will still maximize our tail shaft length on the back so we don't bind unis up when we start to jump this. So, I'm going to leave it there, guys. Thanks for watching, and I'll see you in the next episode when we start chucking the engine in.